Hello and greetings to the respected conference members of the ICECA. This is the presentation for our project named as Prototype for Integration of Face Mask Detection and Person Identification Model for COVID-19 Pandemic. We thank you for providing this sublime opportunity to present and exhibit a model and to render our capabilities. We can use this model as a tool for combating against the entailing problems caused by the virus. This model is an innovation which helps us reduce the tedious and manpower consuming tasks so that we can go on with our day-to-day life. In the face of the COVID-19 pandemic, which has brought the world to a standstill, demands for innovation in health and related infrastructure to resume day-to-day life activities on social and economic fronts, and it has become pretty vital to do that. Masks have emerged as a vital and most handy tool to fight against this invisible enemy. As the governments of world, both at national and international level, are stressing on wearing masks in addition to the social distancing norms, institutional adherence of the same cannot be stressed enough. Therefore, to detect whether a person is wearing face masks or not when in a public space or office, it becomes really crucial. Moreover, it is practically impossible to keep a track of every person or individual in wearing a mask or not. It is a very tedious task to be said. Hence, our face mask detection platform utilizes artificial intelligence network to identify whether a person is wearing a mask or not. In case a person is found without a mask, a notification will be sent to the concerned authority of that institution as well as a reminder to the person in the database of the platform uh, for wearing a mask. The platform will detect multiple streams and recognize if the person is wearing a mask or not using the face detection model. At the point when the mask location model recognizes an individual with no mask, it changes to the individual distinguishing proof model. At that point, the individual ID model distinguishes the individual, and a message briefed enough is shown on the screen mentioning the individual to wear a mask. This cycle is in a circle and continues emphasizing except if and until the individual wears a mask. The people detected frequently will be reported to the authorities by sending a notification to the designated person whomsoever it may concern. CNN use in existing systems are slow and resource hungry, which makes the training process slow, whereas our prototype is efficient, more accurate, and uses less time complex algorithms. The existing scheme does not detect multiple faces, which on the contrary is one of our vital features. The existing system does not detect faces from all angles. Person identification model enhances the usability and not just restricting to a face mask detection. This helps to keep record and send notification in case of a defaulter. The present work does not integrate these three models the way as we do in our model. The mobile net used to train our prototype is small, lightweight, low latency computer vision. This model can run on low-end hardware as well as mobiles. Our prototype will register people with their faces, names, and email ID. These people will have to be registered to the platform prior to the detection process as they will not be recognized by it if they don't. The organization will have to give the platform access to its multiple existing IP cameras, which will act as a video stream for our prototype. The prototype software will have to be installed in a local machine which will analyze the recordings and keep a track of the defaulters. These defaulters will then be sent notifications through mail about wearing masks. This slide represents the flow chart which indicates the prototype actual structure. The employee student registration, connecting the existing IP cameras, a local computer for the prototype to run on, which in turn send emails to the defaulters and makes databases. As the government of world, both at national and international level, are stressing on wearing masks in addition to the social distancing norms, institutional adherence of the same cannot be stressed enough. Therefore, to detect whether a person is wearing a mask or not, when we see them in public spaces or in offices or in colleges, it becomes really crucial for them to wear it. Our beneficiaries consist of large business firms, MNCs, hospitals, schools, colleges, and government offices, etc. These firms, so what you can call them, keep a record of their employees following the post-lockdown social etiquettes of wearing a mask. However, our system fits to all such spaces with an updated data set of regular employees or a person in an organization like the stated in the slide.
Hello everyone, this is Anirudhlodh, and in this slide I'm going to explain why a third eye technology like AI is necessary. It is not possible for a single person to keep track of every person or individual who is not wearing a mask. Our project implementation enables large institutions with many people to work while maintaining safety protocols as set per our governments. These large institutions have hundreds of people, and it is impossible for even a single or even a group of people to monitor them every single day. Make these people aware that wearing masks is essential and mandatory by reminding these people to wear masks. Our project sends notification to the identified person's phones so that we can easily yet efficiently make them aware that wearing masks is essential for their and others' safety. AI technology eases this task by identifying all these people in a particular institute and ensuring that they wear a mask. Our project keeps track of every single person in the institute and automatically identifies frequent defaulters. The project thus eases the task of humans and presents a solution that will make the work and education places safe again. In this slide, I will explain about the workflow architecture of our project. Here we can see the interconnectivity between the modules. The program starts with the initialization of the video stream and the face mask detection model is started. When the mask detection model detects a person with no mask, it switches to the person identification model. Then the person identification model identifies the person and a message prompt is displayed on the screen requesting the person to wear a mask. This identified person is also sent a mail from the mailing system module and his name is added to the database. This process is in a loop and keeps on iterating unless and until the person wears a mask. The figure mentions the complete workflow of the project and gives us information about each module and how it is related to the other modules. This slide briefly describes all the three modules that have been integrated in this project. The person identification model. It identifies the people who are not wearing the masks. The person identification model uses face recognition technology to identify the person. The face mask detection model. This model has been trained by a binary classifier and detects if a person is wearing or not wearing a mask. The face mask detection model also states the accuracy of the detection and highlights the region of interest around the face of the person by a red or green color as per the detection. Mailing model. This model sends mail to people who are recognized by the person identification model. The frequent defaulters' names are also sent to the concerned authorities. The mailing model has been integrated with a database, and this enables the project to identify the people who are frequently not following the rules. This slide shows our complete system architecture. The box on the left with the chakra sign is the mask detection model. This box contains steps that the detection script goes through to identify a person in real-time video stream. A decision is made using the results of the face mask detection model. It branches it into two parts. In the first part, the script keeps on iterating and keeps looking for people who are not wearing a mask. The second part continues to the person identification model and goes through steps to produce a result. The result is then matched with the people already in the database. If a match is found, then the person is sent a notification and this process goes on and on. Our mask detection model is divided into two parts. Model training. For training purposes, we have used MobileNet binary classifier as our neural network algorithm. This algorithm takes two parameters and can be trained with the help of a two-class dataset. Mobile nets are small, low latency, low power models parameterized to meet the resource constraints of a variety of use cases. We went ahead with mobile nets as they are used for efficient on-device computer vision. The face mask detector model script is loaded. The detector model is then used to make predictions and calculate the probability of a person wearing or not wearing a mask. These predictions are looped in for every frame, and for each iteration the detector model is referenced and the values that were trained in the earlier training script are now used. IMUtils was used to call the video stream function, which helps us initializing the video streams over the network or with the help of local webcams on our personal computers. OpenCV was used to make frames and display data in the frames like the predictions and probability. I will explain the detailed workflow of the face mask detection model in this slide. Firstly, the dataset is loaded. The dataset used in this project is made with the help of a script in Python, which fetches free and open source images from internet like Kaggle, Google Images, etc. These images are put into a folder named without mask. An image of mask is then applied to these images in that dataset to make pictures of people with mask. And these pictures are stored in a folder named with mask. Next, the model is trained. Training the model includes augmenting the data, loading the MobileNet binary classifiers. For fine-tuning this model, we have used ImageNet weights. The last step involves saving the trained detector model to the disk. In phase 2, the mask detector model is loaded into the script. The detector model is then used to make predictions and calculate the probability of a person wearing or not wearing a mask. These predictions are looped in for every frame, and for each iteration, the detector model is referenced and the values that were trained in that earlier training script are now used. Now, Utkarsh will continue the presentation.
Hello everyone, my name is Utkarsh Saxena and I am here to present slide number 14, which is the development of person identification module. In this module we have used the face recognition module of Python, and we have created three numpy arrays, or we can say the lists, name as face encodings, face locations and face names. These three numpy arrays are already been located with these images. The images are analyzed for their location, that is ROI, their encodings, that is ROI coordinate, and their names, which are assigned already. The frames in their real time videos are compared with this already existing data using similarity data. We have used OpenCV to create frames and display data in the frames like the predictions, which include the name of the person. So here we can see the workflow architecture of a module, person identification module. Here we are using the OpenCV to initiate the video stream. We are using the face locations to align the faces. Now these aligned faces are goes to feature extraction module. Here, the feature extraction module extracts the features and convert into feature vector, which is used in the feature matching functions to get compared with the preloaded data, and then closest match was found to identify the person. So I'm continuing on to the next module, that is the mailing module of the third module of our project. Here, after the successful detection of a person who's not wearing a mask, the mailing module of our project will send mail notification to the person who is not wearing the mask. The mailing module uses Google's SMTP servers for sending mails notification through Python scripts. The database was created for identifying person, and numbers of times they do not wear mask is calculated accordingly. The frequent defaulter list is sent to the authorities. So let's watch the demonstration of a working prototype. So let's continue with the future work which we want to include. Here we are aiming for a commercial appeal of our product. Here we need here in this time where we need to resume back the normal institutional operations while maintaining the social etiquette of wearing a mask or sanitizing to avoid contacting any infection. Since our project is technology based on AI and ML, integrating various training modules for desired applications, the major step towards this commercialization would be pitching it right to the target audience. It requires some basic capital needs at monetary and human resource level to fulfill some tasks like installation, future maintenance, etc. Rest, the usefulness and performance of the product shall speak for itself and spread the word. The large business firms, multinational companies, and cooperatives which needs to keep a record of their employees following the post-lockdown social etiquette of wearing a mask are identified to be our target customers. However, a system fits to all such specs with an updated data set of regular employees or of personnel in an organization like hospital, school, college, government, offices, etc. Market side determined by the inevitability of its penetration and huge target customer base is in the form of various economic and governmental institutions, schools, colleges, coaching centers, etc. Trying to resume their normal operations stand huge and profitable both at local and national level. We thank all of you for listening to our presentation, that is the prototype for integration of person identification module and face mask detection module. We thank you all. Stay safe.